Okay, today we are working on the 2-4 triangle relationships section. This is a very short section with just a couple of ideas. The first idea is the perpendicular bisector theorem. Now in 2-3 we defined a perpendicular bisector as simply being a perpendicular segment, but we had no idea and no guarantee what would happen at that angle piece. This gives us some guarantees. It says if a point is on the perpendicular bisector of a segment, then two things happen. So really what happens here is if we know a point on the perpendicular bisector. So for example, D, H, and J is on perpendicular bisector M. We get two very powerful pieces of information. We get that it's equidistant from the endpoints. So that means that DG and DE are equal. It means that GH and HE are equal. And it means that JG and JE are equal. And we get that it bisects the angle. So we know that every one of these vertex angles gets bisected. So that one theorem gives us a lot of power. Now we have two theorems here, the angle-side relationships and triangles, and they're really converses of each other. If one side of a triangle is longer than another side, then the angles opposite the longer side has a greater measure than the angle opposite the shorter side. If one angle of a triangle has a greater measure than another angle, then the side opposite the angle is longer. Too many words. So these two are converses, and they boil down to this. The big angle is always opposite the big side. And the little angle is always opposite the little side. Which should make good sense when you think about it in your gut, that a smaller angle is going to need a smaller side to close the gap to make your triangle. So in looking at a couple of examples, we're going to order the sides and the angles. Now in this first one, you have to find the missing third side or third angle. 30 and 65 subtracted from 180 means that angle A is 85. If I'm going to order these from least to greatest, smallest, remember sides are named with lowercase letters that line up with their vertices. So the smallest side is B, the next biggest side is C, and A is the largest side because it is opposite the largest angle. Number 2 is just asking you the reverse to look at the three sides and order them. So my smallest is angle C, that is less than angle B, which is less than angle A. And using less than symbols is another way to express the same thing. Now, the triangle inequality theorem is also very powerful because if you think about it, not all possible side lengths will come together to make a triangle. So what are the criteria to making a triangle? The sum of any two sides of a triangle must be greater than the third side. So this really results in three inequalities that must be true in order for a triangle to be formed. So we go through the process of looking those three inequalities. If one of them is false, a triangle cannot be formed. So we run through, is 2 plus 3, is that, question mark, greater than 5? Is 3 plus 5 greater than 2? And is 5 plus 2 greater than 3? This very first one, 5 is not greater than 5. It's equal. That is false. So therefore, this cannot form a triangle. When we look at the next example and we make our statements, 5 plus 7, is that greater than 9? 7 plus 9, is that greater than 5? And 9 plus 5, is that greater than 7? Go through and check. 12 is greater than 9. True. 16 is greater than 5. And 14 is greater than 7. Therefore, this makes a triangle. Now, just to make the problems a little more interesting, what could possibly be the ranges from the smallest to the largest triangle you could make? So for example, if you wanted to make a rectangular vegetable garden, and you know one side has to be 4 feet and one side has to be 7 feet, how big or small could you make that third side? So we're going to go ahead and set up our 3 inequalities and see what happens. So 4 plus s has to be greater than 7. S plus 7 has to be greater than 4. And 4 plus 7 has to be greater than s. And we're going to solve each of these. So this means that s has to be greater than 3, s has to be greater than -3, and 11 is greater than s. I don't like looking at inequalities with my variable on the right, so I'm going to flip that one over to s is less than 11. This is my top value. Now -3 and 3, -3 doesn't make sense as a length. I'm going to discount that one, and I look at -3. So a nice neat way to write this is s is between 3 and 11. So I could put 3.00001 and it would work. And I could go up to 10.99999 and it would work. That is all for this